Okay, so I want to find, well, first I want to show that an inverse exists for this function by showing that the function is 1 to 1. And then, if that's true, if the function is 1 to 1, if an inverse does exist, then I want to find the inverse. Now, I know enough about sketching, and I know enough about functions to know that this is a linear function, and this function is not a horizontal line. And I know enough about one-to-one functions to know that instead of a vertical line test, well, to be a function, it had to pass the vertical line test. To be a one-to-one function, it also has to pass the horizontal line test, which is the same as a vertical line test, except with a horizontal line. So we have a horizontal line that can't touch the function twice at any point if I drag that line vertically up and down. And so since this is a line and it's not a horizontal line, I know that it passes the horizontal line test. And so I know before I start out here that, that this is going to be a one-to-one function. Now, to actually prove that, to show that algebraically, what I need to do is I need to assume that it's not a one-to-one function, that two different y, that one y value can be yielded by two different x values. And that would look like f of a equals f of b. Two different x values would give me the same y value, the same output of f of x. And now what I'll need to do to prove that this is a one-to-one function is show that for this to be true, a must equal b. And so that the two x values must be the same for this to be true. So let's evaluate this. And so I have 2 times a minus 1 equals 2 times b minus 1. Okay, I'm going to add 1 to both sides of this equation. And so now I'm going to get 2a equals 2b. I'm going to divide both sides by 2. I'm going to cancel those 2's. And I'm going to get a equals b, which does show that for those two y values to be the same, then those two x values have to be the same. And so this, therefore, f of x is 1-to-1, is invertible. Okay, now I actually need to find the inverse function. Now your textbook gives a nice 4-step method for finding an inverse function. The first step, so step 1, is replace f of x with y. And so you're going to have y equals 2x minus 1. Okay, your next step, step 2, is replace all y's with x's and replace all x's with y's. And so that's going to become x equals 2y minus 1. And if I'm being consistent here, I should change that to black ink. Okay. Step 3 is solve for y. Okay, well, to do that, what am I going to do? I need to add 1 to both sides, and that'll give me 2y equals x plus 1. And now I'm going to divide both sides by 2, divide both sides by 2, and I'll get y equals x plus 1 over 2. And then step 4 from the textbook's method is replace y with f inverse of x. That -1 is not an exponent. That's a notation. It's a note that says that this f of is an inverse function to f of x. And so this is f inverse of x is the way you read that, whereas f of x is that without the superscript. So the superscript there is not an exponent. Big thing to remember. So I have f inverse of x equals x plus 1 over 2. Now, if I did that right, if that's correct, I should be able to compose these two functions and get x for an answer, right? Because my definition of an inverse function said that f of f inverse of x was the same as f inverse of f of x, and that I get x out, right? Because each function undoes the other function and leaves me as an output that's the same as my input. And so if I want to check this, if I want to see if I did this right, this is the answer to part B, whereas this is the answer to part A. But this is checking my work, just making sure that I did this right. So if f of x is 2x minus 1, and I'm claiming that f inverse of x is x plus 1 over 2, then let's try f of f inverse of x. Let's evaluate that and see if we get x out. And so that'll be f of, and instead of f inverse, I'm going to put x plus 1 over 2. All right, well, that's going to be x plus 1 over 2, and then there'll be a 2 in front of that, and then minus 1, right? Because I'm putting it into the place of x in my f of x. All right, well, my 2's are going to cancel. That'll leave me with x plus 1 minus 1, which will just leave me with x, which is exactly what I hoped for, because now I have f of f inverse equals x. I could check it the other way too, but it'll work out to the same answer. One other thing that I could do to visually, it's not as good a proof, but it's a good kind of gut check to see if things look right, is I could go to my graphing calculator and I could graph both my function, my inverse function, and then I would graph the y equals x line to see if they look like they're reflected across that y equals x line. And so I'll have 2 times x minus 1 for my first function. I'll have x plus 1 divided by 2 for my second function, and I'll have y equals x for this third function, just so I can see if it looks like the first two are reflected over this green line. I'll go to my window. That's where I want them to be. So I hit graph. And it's a little hard to tell because my scales are off, right? My vertical and horizontal scales are off. But now, let's make it look like that green line's got a slope of 1 or a 45-degree angle. Now that I can see that I've kind of got the same distance in x and the same distance in y, the scales are equal, it really does look like the red line flipped over the green line becomes the blue line. And that's a characteristic of inverse functions, is that they're reflected across that y equals x line, because the y and x axes have been exchanged. I hope that helps us as we're showing one-to-one and as we're evaluating and finding our inverse functions.